Hello everybody. Today we will be answering parts A, B and C of your homework. Question 2 in page 246. First, let's make a quick revision on the basics of that chapter. This chapter is named Trigonometry, which is chapter 12 in your book. The sections that are required are just sections A and B. Trigonometry means the study of triangles. This is a note to be stated. Trigonometry is the study of triangles. In this chapter, we will be focusing only on right triangles. This is our concern. First, let's study this right triangle in the margin. Suppose that this angle is a 90 degrees angle, and this angle is called theta. Theta is just a Greek letter, like X or Y. So this is a 90 degrees angle, and this is theta. Now, we know that each triangle has got three sides, but after theta has been specified, these three sides attain special names. First, there is a side that does not touch the angle theta. Spot that side in the triangle you see in the screen. Here is it, the side that does not touch theta. This side is called the opposite of theta, and it is the side that does not touch theta. Does not touch theta. Next, we have got another side, which is the side that touches both theta and the 90 degrees angle. Theta and the 90 degrees angle, it's called the adjacent of theta. The adjacent of theta touches, or just colon, touches both theta and the 90 degrees angle. And finally, there is the side that does not touch the right angle, which is, as you see, that side there, which is called the hypotenuse, and we know this from previous classes. Great. So the hypotenuse there, HYP or just H, regardless, does not touch the 90 degrees angle. Great. These definitions are to be memorized by heart. Next, we move to another three definitions that need to be memorized by heart. Three names, three ratios are to be introduced. Sine of the angle theta, the cosine of the angle theta, and finally the tan of the angle theta. So these three definitions are just ratios of lengths. The first definition there, sine of theta, is just the length of the opposite of the angle theta divided by the length of the hypotenuse. Next, cosine is just the length of the adjacent of theta over the hypotenuse, the length of the hypotenuse, and finally the tan of theta is just the length of the opposite of theta divided by the length of the adjacent of theta. Okay, these also are to be memorized by hearts. So we are just dividing some sides of that triangle. Okay, let's now go to the homework and solve parts A, B, and C. Great. This is question 2. Find x rounded to 2 decimal places. Parts A, B, and C will be solved in that video. Okay, let's copy the triangle. Sorry. I'm drawing the vertical side right now. And I'm drawing the hypotenuse. Great. Okay, regardless of these extensions. So let's mark the known side. It is just the 15 there, 15 centimeters, specify the units, and there is the 30 degrees angle there, and finally there is the x centimeters side, and we would like to know the value of this length x. Okay, as a first step, just construct that table. Okay, next, in the first row, write always opposite, adjacent, hypotenuse, and write the values of the sides that are known, that are provided. First, what is the opposite in this case? The side that does not touch the angle. It is unknown. Great, so just write a question mark. Next, the side that is adjacent to the angle, the side that touches both the angle and the 90 degrees that I'm gonna mark here. Of course, it's x, correct. So just write x. Finally, the hypotenuse, the side that does not touch the 90 degrees angle, correct, it's 15. Now, just mark the side that you want to know and another known side. In this case, only the hypotenuse is known. Link both together, these sides both together. They are the adjacent and the hypotenuse. Next, go above to these three ratios that are to be memorized by heart. Where is the adjacent and the hypotenuse? Where do they appear in one ratio? There is the opposite there above, so it's not the sine. There is the adjacent and the hypotenuse there, so it is the cosine. So the cosine links or collects together the adjacent and the hypotenuse in one ratio. So just copy and paste that below here. The cosine of an angle theta is just the length of the adjacent of that angle theta divided by the length of the hypotenuse of the triangle. Okay, just copy and paste the known values. Theta is just 30 degrees, so just write this is equal to, okay, cosine of, instead of theta, I'm gonna plug 30 degrees equal to the adjacent of theta, the side that touches both theta and the 90 degrees angle. It is that side here, that side there, that side here, and it is equal to x. Great. And the side that we want to know, divided by the hypotenuse, is just 15. So x over 15 is equal to the cosine of 30 degrees. Okay, we want x by itself on one side, so just multiply by 15 and multiply by 15 here. 15 cancels 15, and x is just equal to 15 multiplied by the cosine of the angle 30 degrees. And that's it. Now we can go to our calculator. Great. Just type 15 multiplied by the cosine, and you will find that button in your calculator. It's cosine of the angle. What is the angle? It's just 30 degrees. So the answer is 12.99. And the question asks us to write for two decimal places. 12.99 for two decimal places is just 13.00. And the unit of that length is similar to the unit that was presented by the known length. It's centimeter there. So it's centimeter. And the answer was taken for two decimal places. That's it. Great. Let's move to the other example. It is B there. So let's copy and paste it. Let's specify the 90 degrees angle. It's there. Here's the 16 centimeters side, and this is the x centimeters side. And this is the known angle, 76. Okay, as above, just construct the table. Write opposite, adjacent, and hypotenuse. Opposite of theta, opposite of the angle here, the side that does not touch the angle. It is x. Adjacent, that touches both the angle and the 90 degrees, unknown, unspecified, and not required. The hypotenuse, the side that is known, in this case 16. So just mark 16. Okay. Choose the side that you want to know and another known side. In this case only 16. So the opposite and the hypotenuse. Get back above. Opposite and hypotenuse. Where is the ratio that collects both? opposite and hypotenuse. It is the sine there. So just write sine of the angle equals the opposite of the angle over the hypotenuse. In this case, the angle is just 76. So I'm gonna write 76 there. The opposite is just x, and the hypotenuse is just 16. So as before, multiply by 16 to get rid of the unwanted number there, to let x be the subject. X is just equal to 16 multiplied by the sine of the angle 76 degrees, and that's it. So just going back there, 16 multiplied by the sine of the 76 degrees angle is 15.52 for 2 decimal places. So x is just equal to 15.52, and the unit was given in centimeters, so the unit there will be in centimeters to 2 decimal places. Finally, part C. Okay, we have got this 90 degrees angle, right triangle, I mean. So there is a 4.8 there, 4.8 meters and x meters, and an angle of measure 64 degrees. Great. The table, opposite, adjacent, hypotenuse. Opposite is just, in this case, the side that does not touch the angle. It's just x. Adjacent, that touches both the angle and the 90 degrees, 4.8, and the hypotenuse, in this case, unspecified. The two sides that are, one of them, the side that I want to know, one of them is the side that is already known, are the opposite and the adjacent. Okay, go back above. What is the ratio that collects them in together? So opposite over adjacent there, tan theta. Great. So tan of theta is just equal to the opposite x divided by the hypotenuse, by the adjacent 4.8, and theta in that case is just 64. So am I right? Okay, tan 64 equals to x over 4.8. Multiply both sides, 0.8. Multiply both sides by 4.8. So x is just equal to 4.8 tan of 64, similar to the arguments used above. Now just plug this into your calculator. 4.8 multiplied by tan of 64, 9.84. Great. X is just equal to 9.84. The unit was in meters in that case, and this was taken for 2 decimal places. You need to specify an indication of the degree of accuracy. Okay, and that's it. A final note now that you may encounter, just a quick indication of this, a quick remark. Suppose that we're going to solve this part E. I'm not going to solve it until the end, just to specify how to construct the formula for the final answer, the expression, for the final answer. We have got that 8.2. 8.2 is that side there, and it is measured in centimeters. Next, we have got x centimeters, and finally, there is this angle 68 degrees, and the right angle is there. Okay. As before, just write opposite, adjacent, and hypotenuse. Opposite of the angle 68 is 8.2. The adjacent is the side that touches both, is just x, and the hypotenuse is unspecified. So we know that we want to mark x, the side that we want to know, and another known side, 8.2, both together, opposite and adjacent. So get back above you and you will find that the ratio that collects these is the tan ratio. Tan of the angle 68 is equal to opposite 8.2 over the adjacent x. Now the new thing here, that is x appears below. x appears in the denominator. How can you get rid of that problem and let x be the subject? Okay, it's simple. Just recognize that tan is just tan over 1, and you can cross multiply. Next, you can write 1 times 8.2 is 8.2. I'm cross multiplying right now. Just cross multiplying. 8.2 is equal to x multiplied by the tan of 68. There is a multiplication there. I want to get rid of anything next or surrounding x, so just divide by the tan of 68. Don't calculate tan now. Calculate everything, plug everything in your calculator after letting x be the subject. So over tan of 68, this cancels that, and x is just equal to 8.2 divided by the tan of 68. And that's it. So x is just equal, let's get back there, construct a fraction first, 8.2 divided by the tan of 68. 3.31 for 2 decimal places. 3.31. The unit was part E in centimeters, so this must be in centimeters, and for 2 decimal places. That's it.